Honors Pre-Calculus students, in this video I'm going to explain what is a sum and difference identity and how do we use them. So let's take a look at page number 17 in your packet. This is the identity packet, page number 17 in the identity packet, which is the sum difference. So why do we have to use them? We are going to apply, we are not going to derive, we are not going to do the proving part, we will just use them, apply them for sine, cosine and tangent, for sum and a difference of angles. Why we learn this? So think about, this is the algebra of a real number. For example, is if we know that 2 times x plus y, we always distribute. But what happens if we have sine of x plus y? Are we allowed to distribute? Interesting. So let's take a look at this warm up. Let's say x is a 90 degree and y is 180 degree. So sine of x plus y, is it same as sine x plus sine y? Pause the video here and try this warm up yourself and you tell me whether this is true or false. Okay, welcome back. So what will be sine x plus y? So this is 90 and 180. This becomes sine of 270, and we know that the sine of 270 means the y coordinate on the south, which is -1, versus sine of 90 plus sine of 180. 90 is up here north and 180 is on the west. So 1 plus 0, this answer comes out 1. Whereas sine of x plus y is sine of 270, the answer is a -1. So the purpose here is, again, is it possible? Can we distribute sine x plus sine y? We say no, that's not possible. Clearly, based on the unit circle, y coordinate here is -1. This is 270 degree. This is a 90 degree, y coordinate is a 1, and 180 degree is on the west, y coordinate is 0. 0 plus 1 is not -1. So no, you can never distribute any of those functions, not only for the sine, this is true for any trig function. Let's take a look at the analogy that if you have a log of 2 plus 3, do you think that is the same as log 2 plus log 3? Is it true? Now, some of you would say, yes, that's right. We learned this, that log plus log is, that's not true. You can never do it. The true is only product of log is. So we have a rule. We have to do this based on the rule. We did prove this in the log unit. Here in the sine trigonometry unit, we are not going to prove, but we are going to use the help of unit circle, and we see that clearly that's not true. So let's take a look at second warm up. Here is 15, 75, pi over 12. These numbers are not on the unit circle. So how do we use unit circle angle to evaluate sine of 15 degrees? Sine 15, I'm not talking about putting in the calculator. No, this is without using calculator. How do you evaluate sine of 15? Clearly on the unit circle 15 degrees not there. So the question here is, how do we express as a sum and a difference using special angle? Special angle means the unit circle angle. And answers are not unique. That means you can make a 15 degrees so many different ways. So I would like you to pause the video here and then check it out. How do you make 15 degree using a couple of examples from the unit circle angles? Okay, so let's talk about 60 minus 45 is 15. Somebody say, can I use a second quadrant angle? That's also 15 degree. Can I use a third quadrant angles? That's also 15 degree. So clearly 15 is a smaller number, and the smallest number on the unit circle is a 30 degree. So you have to use difference to make 15 degree. Sum of the angles, you can make sum or difference. So let's take a look at 75 degree. 75 degree, can I write it as 45 plus 30? Yes, you can. Now, how about radians? Radians is do not change to degrees. Do not change to degrees. You are wasting your time. Do not change to degree. In fact, forget about degrees. What is degree? We don't know. This was just example. Here we always use radian. So what is the trick to get the combination of pi over 12? Think about the 12. What are the common denominator gives you 12? You can use 12 and 1, but 12 is not on a unit circle. So 12 and 1 is not going to help. 6 and 4, 6 and 2, what would you use? 6 and 2. 6 and 2 will not give you common denominator 12. 6 and 2 will give you common denominator as 6. So just think about fractions. What fractions I could use? Another reason is, another thing to think about is, would you add or subtract? Pi over 12, pi is a here, pi over 12 is a very small angle, and get the idea that you will have to subtract. So I'm just giving you the answer here. One of them, the easiest is 3 and 4 gives you 12, and 4 pi minus 3 pi gives you pi over 12. So this is one of the combination. Another combination is you can play around with these numbers. 3 pi over 4 minus 2 pi over 3 will also gives you pi over 12. If you don't trust me, you can find the common denominator and check it out. So how do we know that we have to add or subtract? Again, think about the size of the angle. Angle is so small, obviously you will have to subtract. Some angles you can add and get the bigger answer. This is possible with the subtraction also. Pi over 12 is very small angle, so that's why we are subtracting. Now this is my favorite part of the thing is Hall of Fame of algebraic blunders. Remember you watched the other video and I asked you that what's the common mistake you have done? Many students said that this is the one they have always made the mistake. They forget the middle term. That's why I call it Hall of Fame of blunders, because this is the most common mistake. Do not do this. This is not true. That's why it's in blunder, Hall of Fame of blunder. The correct answer is you should know that there is a middle term. Another one is also here. Many students say that, oh, they have always done this. They have always done this. Well, this is never true. You can check, substitute any numbers and you will see if it is true. This is only true if it is multiplied or divide. Yes, you are allowed to split if it is a product or if it is a quotient. But if you are adding, subtracting, that's never, never, never true. Okay, so this was just the hook of the lesson. What is actual lesson? So let's flip the paper and we check it out. So next page, page number 18 is unit circle. This is the unit circle. Again, it's never going to leave you. You should know all the values, all the angles and ratios in radians, degree. I'm not going to teach this again. You should know this forward and backward. This is the forward. We are after the spring break, when we do the vectors unit, we are also using unit circle. So keep the unit circle handy. That's one of the main tool in your toolbox. Okay, so skip this page as well. So let's take a look at page number 20. I believe this is your page number 20. We are not going to prove it. I'm just explaining these formulas. So cosine x plus y, where this formula come from, we are not proving it. We know that we never distribute. We know that we never distribute. So let's understand this sum difference. If it is a plus, is a sum, difference is minus sign difference. What this formula is, cosine x plus y is cosine x times cosine y minus sine x times sine y. So another way to see is cosine is always cosine, cosine, sine, sine, and the opposite is the middle, opposite sign. In the middle is the opposite sign. Know the sign change. If it is a sum, that the subtraction. If it is a difference, then you are adding. So easier way to write is, again, practice cosine of x plus y, I'm writing one formula. There is not actually two formulas. There is only one. If the difference is, you can write it as x plus negative y. That will be the difference. You can write the difference as a sum. And then you can substitute y as a negative y, but we know that the cosine is the even function, and that's why it does not change. The first two terms product, plus or minus, you can see that the first two terms are same in a product or, not product, sum or difference. Sum or difference, the first two terms are, first product is the same because cosine is the even function. Then the sine is negative y, replaced with negative y, it becomes negative because sine is the odd function. So cosine, cosine, cosine x, cosine y, opposite sine, sine x, sine y. So these are something new formulas. You will get used to it, and don't worry about memorizing. They will be given to you in the problem. Normally you get the formula sheet. If you are sitting in the classroom, you get the formula sheet. Formula sheet has these formulas given to you. So this is for cosine. Let's take a look at for sine. Sine of x plus y is, notice first thing, if it is a plus, that's a plus. If it is a minus, then it's minus. So sine does not change. Then it's alternate function, sine, cosine, cosine, sine. Check it out again, sine of cosine and sine, they are alternate functions. So let's try to write it down. Let me explain here. And I always say that the sine has the same sign. Think of that way. Sine, some difference of a sine function has the same sign. There we go. So sum of two sine function, sum of the two angles have a same sign. Sine has the same sign. Okay, then write it, sine, cosine, sine x, cosine, and then x and y. This is the formula. You never make a mistake. Again, do not stress out to memorize this formula. It will be given in the formula sheet. You just have to get familiar with this formula. The third one is for the tangent. Now notice tangent formula, you can do two different ways. We know that the sine theta, sorry, not sine, we know that the tangent theta is sine over cosine. So you can write it as a quotient of sine of x plus y divided by cosine of x plus y. But tangent says, why do we use all the time sine and cosine? I can have my own formula. Yes, tangent has its own formula as well. Tangent is the only one which has a quotient. So I will explain this when we do the problem here. So first of all, let's take a look at a couple of examples, and then you can practice, and we will save some time in the class. So 105 degree exact value. Let's understand what is exact value means. Exact value means no calculator. This is not that easy that you just punch in the numbers on the calculator and get the answer. No, exact value means no calculator, answer in the simplest fraction. 105 degree is not on the unit circle either. What unit circle angles we can use to make 105 degree? So, and there is more than one way you could do it. More than one way you could do it. So some says, can we use 60 plus 40? 60 plus 45, sorry, 60 plus 45 is 105. Somebody says, can I subtract? They don't want to pick this easy answer. Somebody says, oh, I want to take the challenge. How can I make 105 using some other numbers? 240 minus 135, that's also true. I would not recommend to challenge yourself at this time. Just use the first easiest one. Watch one option, that's all. Just stick to the one option. Another reason not go in the other quadrant also, because sine and cosine are sometimes positive, sometimes negative. So let's pick the easiest option here. I'm rewriting this as 60 plus 45. This is my first step. Second step is, you have those formulas up on your page. So I'm just writing using the formula. This is cosine 60, cosine 45. degrees minus sine 60 sine 45. Okay, one more time. Cosine, cosine minus sine, sine. Cosine has the opposite sign. Sine has the same sign. Okay, so what do we do next? Well, I would recommend draw the parentheses so that you are not mixing up the values. Ratios. We have to use the ratios. Cosine of 60. Cosine of 60. If you prefer those special triangles, you can draw them. Cosine of 60 is 1/2, first quadrant. If cosine 60 is 1/2, sine 60 cannot be 1/2. They are not same. Remember, they are not same. 60 degrees, not the two legs are never same. So cosine 60 is the adjacent is 1/2. So that means the opposite is √3/2. Cosine 45, sine 45. Both legs are same. We know what that angle is. Cosine 45, sine 45. We know that cosine 45, the two legs are same. So that means both numbers are same. Here, I'm not going to write 1/√2. I want to use √2/2. And you will see why. Remember in the beginning of the identity units, I told you that my preference is 1/√2. You can write it. My preference is √2/2 here. Let me explain why I chose √2/2. The reason is when we simplify this, remember you are multiplying this. So when I multiply, it's so much easier that 2 times 2 is a 4. 1 times √2 is √2. Minus 2 times 2 is a 4. And √3 times √2 is √6. Final answer is common denominator 4, √2 minus √6. Now remember that Hall of Fame of blunder, you cannot combine this together. This is not a √4 or negative √4. No, you are overdoing that. Stop here. This is your answer. Yes, it looks different, but that's what the answer is. That's what the answer is. If you don't believe, you can put in the calculator degree mode cosine 105 and then separately subtract √2 minus √6 divide by 4. You can compare your answer. It will be the same. So this unit is a fun unit. We don't have to use fancy formulas or identities. This is just one identity and it will be given to you, of course, and you find the answer. So why don't you practice some more questions here? I give you, let me explain one here. The rest of the problems we will be doing in class. So cosine 13 pi over 12, 13 pi over 12. Remember pi over 12 is 3 and 4. So let me explain here how do we get the combination. Why do I have to add? Because 13 over 12 is a more than 1 pi. 13 over 12 is more than 1 pi, which means I can easily add the angles. So let's say I keep 1 and I keep, a 3 and 4. So 3 times 4 is a 12. Now guess and check that they all have a pi. So 3 pi and 4 pi will give me 7 pi over 12. That's too little. Look at the unit circle angles. Check. Put this here 2, let's say. 4 times 2, 8, 9, 10, 11. I need 13. So this doesn't work. 3, let's say. 3 times 3, 9, 10, 11, 12, 13. Yes, this will work. So cosine of pi over 3 plus 3 pi over 4 and cosine pi over 3 cosine 3 pi over 4. Remember, these are the angles. These are the angles. If you want, you can put a parenthesis minus sine pi over 3, sine 3 pi over 4. Very similar. Now, all we need is the unit circle ratios. not the degree. You are not changing to degree. Make the 4. Cosine pi over 3 is the same as the 60. We know that cosine pi over 3 is the same as 60 degrees. I'm going to borrow those numbers here. Sine pi over 3, 60 degrees, root 3 over 2. Okay, so now let's take cosine 3 pi over 4. 3 pi over 4 is here. Cosine is going to be negative. Sine is going to be positive. 3 pi over 4 is the same as a reference angle pi over 4, which is, this number is going to be negative root 2 over 2. Second quadrant, cosine is negative. This will be positive root 2 over 2. And my answer will be, if you simplify, negative root 2 over 4, and 3 times 2 is a 6. That's the answer. So somebody would say, why these answers are similar looking answers? Sometimes even you will have the same answers. Why? Why? Answer is very simple, because you have seen on the unit circle, all the values are repeating. Don't you see that? This number is the same as here. They are repeating. That will be the same as here. Numbers are repeated. So many, because you can look at this reference angle, all STC, all those answers will be similar looking. Sometimes you get the same answer even, but not a big deal. So don't get concerned that your answer looks weird. It's not weird. This is the answer. So why don't you practice on some of the questions on this, and we will go over the answers tomorrow in class. If you want, you can begin the work on the homework. Homework is this page. Why don't you begin work? Oh my gosh, did I do the same question? This is the same as question number 1 in the notes. We just did it. Copy or do it again. So this is the homework. You could begin work, or we will go over them in class. I hope you learned something today. Thank you.